In this video, I will demonstrate how to test for correlation between X and Y values. We just want to see if there's a linear relationship between them. And we will use MS Excel and a scientific calculator to compute the correlation coefficient. So the problem states the following. Assume that an instructor would like to test for correlation between the hours of time students spent studying for an exam and the score each student received on the exam. The data set is presented below. Use alpha equal to 0.05. So we have all the time spent by a group of students preparing for an exam and the actual exam scores. Step 1, we draw a scatter plot by plotting points on the coordinate system. In this example, we will use MS Excel to construct the scatter plot. To do so, you select all of your X and Y numerical values, click on Insert, and we go to the chart section, click on this option for the charts, and then I like to select this scatter plot option. Let's resize it, and we'll put a title. We'll just list scatter plot. We can then analyze the scatter plot, and we can come up with a rough estimate that it does look like there is a linear relationship. As the X values increase, the Y values increase and slope upwards. Let's copy over the graph onto the document. The next step, we have to state the claim. In this section, the claim will always be rho equal to 0. Even though this looks like a P, it is the Greek letter rho, and it stands for rho equal to 0. That's our claim. This statement essentially means there is no linear relationship. H sub 1 is rho not equal to 0, and this statement translates into there is a linear relationship. Step 3, we draw the R bar. Here's the R bar. And we look up the critical values in table I using alpha, which is 0.05, and degrees of freedom, n minus 2. So degrees of freedom, n minus 2. N is the number of pairs. There's 8 pairs. 8 minus 2 is 6. So we turn to table I to look up our critical values. And so table I is provided with the book. Alpha 0.05. We go down 6 to 0.707. So we have our two critical values, negative 0.707, positive 0.707. Next, we compute R, the correlation coefficient. And first, let's compute R using Excel. So to compute R using Excel, we would click on an empty cell in Excel, type in an equal sign, and type out the function correl with the 2 R's. Parentheses, select the X values, comma, select the Y values. Close the parentheses. We have R, it's 0.950. And we can also use a scientific calculator to compute R. To do so, we have to first type in all the pairs of the bivariate data. And I've done that already beforehand. Next, we have to click on Second Stat. And then select two variable statistics, press Enter. Make sure L1 is selected, L2 is selected. Click on Calculate. Use the down arrow to go down to R, and we could see that this is the same value that we computed using Excel, 0.950. You can also use the formula, or if you have a different calculator, I do have videos that I developed in the past that you can refer to. So back to the problem, we see that R is 0.950. R falls in the critical region, so we would reject H naught. And if we reject H naught, we can state that there is a linear relationship. The next step in the process would be to find the line of regression. Thanks for watching the video.